Hello everyone, my name is Daniel Balog. I'm from Luciad, and I'm here to discuss the terrain data exchange research we did within the OWS 10. So one of the main drivers for this research are the requirements set out by ICAO Annex 15 and ADQ. ICAO Annex 15 is an international standard describing how aeronautical information should be gathered and managed in civil aviation. ADQ stands for Aeronautical Data Quality and can be considered as an enhancement of quality requirements at the EU level. A major requirement defined by these standards is the need for member states to provide terrain and obstacle data in electronic form. For obstacle data, AXIM 5 can be used. But for terrain data, although many different formats exist, no format has yet been identified that fully satisfies ICAO and ADQ requirements. Another open question related to the provision of terrain data by member states is how to make sure that there are no cross-border issues. And finally, there's a growing interest in providing web-based access to the data in an INSPIRE-compliant way. So it is also an open question how this should be done for terrain data. So the goal of the research is to analyze these questions and problems and identify recommendations and evaluate a number of candidate formats that comply with the requirements. An important part of the research was to identify candidate terrain data formats. So we selected 3 promising formats, namely TIXM from Eurocontrol, Elevation Surface Model from the DigiWig, and OGC GeoPackage, which was released earlier this year. For the evaluation, we used 6 criteria. Apart from the compliance with ICAO Annex 15, ADQ, and metadata requirements, we also looked at OGC services integration, completeness, scalability, and industry adoption potential. Details of the evaluation can be found in our engineering report, but here are a few highlights of the results. The TIXM format scored best on compliance with ICAO Annex 15 and ADQ, and also had the most concrete metadata support. The GeoPackage format scored best on scalability because of the many built-in features like selective decoding, support for aggregate data, and sparseness. The ESM format is the most comprehensive one. It has a wide range of features and provides support for various data representations. Now, apart from format evaluation, we also looked at the topic of providing seamless terrain data. As set forth by ICAO, member states need to provide terrain data. However, due to differences in national geodetic systems, a problem is how to provide cross-border seamless terrain data. A few approaches have been researched to obtain such data. The first and most simple approach is to shift the responsibility to the clients to merge data sets from the different member states. A second approach is to let the states agree upon a grid and reference of the terrain. Each node of this grid is then assigned to a single state. A third approach is to centralize the terrain data provision by a central authority, with each state responsible for collecting data for an assigned area. The engineering report discusses these approaches in more detail. A final research topic is the provision of web-based access to terrain data in an INSPIRE-compliant way. INSPIRE is a European initiative to harmonize representation and delivery of geographical data. For elevation data, it also identifies a number of requirements that impact the data representation and exchange. Speaking of the results, we can state that OGC WCS is one of the recommended web services to be used to directly access terrain data. To access terrain data in a rendered way, OGC WMS and WMTS are recommended services by INSPIRE. So to conclude, the terrain research targets the following benefits for the stakeholders. First, a selection of candidate terrain formats has been identified and evaluated that not only comply with ICAO Annex 15 and ADQ, but also do well on criteria relevant for the implementation and widespread use, such as industry adoption potential and scalability. Second, guidance is offered on how to provide seamless terrain data across national borders. Finally, guidance is also provided on how to access terrain data in a network, taking into account requirements set forth by INSPIRE.